Hello, in this video I'd like to show you how to use Moose, which is a platform for software and data analysis, and it's built on top of Pharo, which is a programming language and development environment. I prepared a list of steps to teach you how to set up your environment to start working with these tools, and then I'll show you a small example of software analysis that we will do with a small Java project. And then we're gonna parse it and load the model into Moose, query the model, and use some visualizations that can be useful for you to understand the system that you are analyzing. And I will explain how to generate these visualizations and what they mean. But first of all, I'm gonna show you how to download the Pharo launcher. So you can go to pharo.org. As I said, it is a programming language, but I'm not going into the details on how to code on Pharo on this video. So if you want to learn, you can click here on learn and go to the Pharo mock, which is a series of videos where they teach you everything about Pharo. But for now, let's click on download, and then you have the options for Windows, Mac, and Linux. Currently, I'm using Ubuntu, so I'm going to show you how to do it in Ubuntu. So for Ubuntu, basically you click this button here. You're going to download a zip. I already downloaded it. Then you unzip it, and then you're going to have something like this. Then you can open a new terminal inside of the folder that you unzipped. And then you can simply execute the Pharo launcher. You should see a window like this. And for you, if you never used Pharo before, this list is going to be empty. This list here, where I'm clicking, shows all your Pharo images. So Pharo works with a virtual machine, much like Java. These images are for other projects that I'm working with, but I'm going to create a new one for this tutorial. So you can go here on New, on the top left, you can click it. You'll see there are many options of images and versions. So Moose 10 is also using Pharo version 10. So the versions of Moose and Pharo always match each other. Then you click on it, and then you can create image. It's going to take a while because it's going to download everything that is needed to create the image. You see here in the list that there are some images that are just called Pharo. It doesn't say Moose. So these images are for when you want to work with Pharo, but you don't want the Moose analysis tool in the image. You don't want the image to come with Moose installed. You see that it will appear here on top of the list. I forgot to show you, but you can actually give a name to the image before you create it. If you want to give a name after you create it, you can always click with the right button and go to rename. And then let's give it a name like Moose tutorial. Accept. You will see that it's going to be renamed. Here you see architecture 64 because I'm running Ubuntu 64 bits version, and the Pharo version says 100, so it's a Pharo 10, and last modification date. So you can click on it and then click here and launch. So you see it launches very quickly. Here we have Moose, but that's it for now, because our next step after downloading Pharo and creating a Moose image, now we need to choose a project that we want to analyze with Moose. So this is going to happen outside Moose, okay? So I'm going back here. I'm going to click here on top and just quit for now. Discard changes because we don't have any changes. And then let's choose a project to analyze. So I chose this engine called, it's a game engine, a tool to create games called Liddy Engine. It's a small open source game engine, but you could choose any Java project that you want. So what I did is I cloned it. I cloned it into my computer. So you see that here I have inside of Lady Engine SRC, I have all the Java files for this system. And then, okay, this is all you have to do. Just come here, code, clone. You can choose if you want to clone HTTPS or SSH. You choose a folder on your computer and you clone it. Here I created inside of my desktop a folder called Moose Tutorial, and then I clone Lady Engine there. Then, next step is you go to VerveineJ. So VerveineJ is a parser that is going to convert all this code that we have here for Lady Engine or any other system. It's going to convert this Java code into a model, which is saved in an MSC file, .msc file. And this MSC file we will later load into Moose, okay? So to clone VerveineJ, you do the same steps. You can clone HTTPS or SSH. You can copy the commands here, or just go up here on GitHub. Once you cloned it, like I did here, I cloned it in the same folder, in the same Moose tutorial folder as I have Lady Engine. And then you'll see that we have here all the code for the parser, but we won't touch this code for now. The only thing that we're gonna do, so now we are in step 5. So we're gonna run this parser to generate an MSC file for Lady Engine. So I'm gonna do this from inside the Visual Studio Code. You can go here on Terminal and New Terminal. And then you open a terminal inside Desktop Moose Tutorial. Then if we type ls, you're gonna see that we have the two folders here and the README where I'm reading these instructions. You can go into VerveineJ folder, ls again. Here you'll see this verveinej.sh. This is the file that you want to execute to parse Lady Engine. And remember that you have to execute it with bash, not just sh. If you just do sh VerveineJ, it's not going to work. You got to use bash. And then as the only parameter to this bash script, we have to pass the path to the Java system that you want to analyze. So I will click here with the right button and copy path to Lady Engine, and then go here in the console and paste it. So I'm gonna run VerveineJ on Lady Engine, and then you enter, and it runs. And actually, I forgot to explain, and it's actually not stated in the README as well, but to run VerveineJ, you will need Java 17 installed in your system. So no matter the operational system that you're using, before running this, you have to install Java 17. You can go to Java's website and download the JRE version 17. Okay, and then after you have Java set up, you do the cloning, you do steps 3 and 4, then you do step 5, run VerveineJ. You'll see that it takes a while, it prints a lot of stuff in your terminal. Then when it's done, you can go into VerveineJ's folder, or here I already have it open. Oh, actually I don't have it, so let's open it. So you will see here that you have a file called output.msc. So this is the file that is the model representing the application that you have in your target folder. Okay, so this is the file that on step 6 we're gonna load into the Moose image. So you can go back to Pharo, which is still open here. You can open the image that we created just before. So Moose tutorial, launch. Then you can go here into the second menu item, Moose. Click in Models Browser. you'll see this small window open. Then here on the left side, you see a small button that says File, Import Model from MSC or JSON file. You click on it. First of all, you have to choose the kind of model that you want. As a default in the Moose image, you come with this model. So Femix ST model, this is for Smalltalk. Femix Java model, which is for Java. And then you have this other test model, which I don't know what it is. But for now, we're going to use Java model. So you select Java model. Then for the file path, here you're going to pass the path to your model. You click with the left button on this button here on the right. Then you can search for your model. So mine is on my user folder, desktop, Moose tutorial, VerveineJ, output.msc. You click on it, you click OK. Here you can change the name. Let's call it tutorial. You keep all entities selected and then you import. And then here on the left, top left side, you will see the progress. It says parsing output.msc. So it's parsing the file and transforming it into a format that Moose can understand. It's creating all the entities of your model inside of Moose. And then here you have it. So if you click inspect, you'll see a long list of all different names and stuff. So these are the entities of your model. And the entities of your model represent all kinds of structures that exist inside of your Java code, like classes, methods, attributes, variables, etc. This is all created by the parser. So if you work with parsers for other languages, they may divide things in a different way. You may see different entities here. But I know this long list of entities is not very clear as to what is inside of this model. So you can close that. You can first of all click propagate. So we can access these entities in the other windows that I'm going to open here. And then you can click on Moose again and go to Queries browser. And so down here in this browser, you can see the types of entities that you have. So annotation types, attributes, classes, enums, exceptions, interfaces, local variables, methods, parameters. So if you're familiar with Java, or for instance, if you're familiar with any object-oriented programming language, you will recognize these names. So these are all structures that exist inside of your source code. But for the visualizations, we don't always want to visualize, or sometimes we can't visualize them all together. So in the queries browser, we can filter them by type or by name or by all kinds of different stuff. So you can click here on the plus on the left side of the window. Then you'll see a new line here saying please select a query. Then if you click on this combo box, you will see all the options of queries. We'll start with a type query. It will give you this button, select types. And then let's say for now, I want just the classes. I want only classes and methods. So you see, as soon as I select here, I see that inside of this model, there are 558 classes, 6,289 methods. You'll see sometimes repeated names. It might be because you have many methods with the same name in different classes. Sometimes you may also see some weird methods without, like with a blank name or with weird names. Sometimes it might be a problem with the parser, but here it seems like the parser did a very good job parsing the Lidi engine that we use as an example. Here you see all the classes as well. And so let me start just with the classes. And I'm going to show you the first visualization, so the architectural map. So we select the classes, we propagate them. So every time that you want to select something, you have to propagate it. So the other visualizations will only consider these things that are selected and not all the entities inside of your model. Then you can go to architectural map, and it might take a while to open, especially when you have lots of entities. And here it is. So if we zoom in, you can zoom in with your mouse wheel. You'll see all the classes in your application here. And if you right click and do expand, you'll see the entities inside of class. So here you're seeing methods. We can see by the name that they are methods: get, grid, get, intersected nodes, etc. If you expand on the methods, if your parser work correctly and if there are things to be seen there, you might see reference to variables and parameters and things like that. They're inside of the methods. You can click expand and collapse to visualize as you wish. You can drag things around. And one of my favorite things to do with the architectural map is not only seeing the entities, but the relationship between the entities. So you can go here on settings, and this small box is going to open. And you can click here on links to show. You can click on change, and then you'll see some links between things that you can see. For example, invocation, reference, access, inheritance. So these are all relations between things. So for example, when you do a function call inside a method, that is an invocation. So you could create a call graph by using this visualization. When you do an extends, when you write extends on your class, you're doing inheritance. So for example, let's see inheritance relationship between these classes. You can click OK, then OK again. It's going to take a while because there are many classes and probably many inheritance relationships as well. So here you can see now that there's some strokes, some arrows between the classes. So this is showing the inheritance relationship. Of course that there's a lot of stuff and it's pretty hard to visualize, but when you hover with your mouse, you can see that the related classes are all highlighted. So when I hover with my mouse on property panel, you see other classes that inherit from it, like movement panel, prop panel, light source panel, spawn point panel, etc. If you wanted to maybe see it better, we could drag it around. Unfortunately, there is no like automatic way to do that yet, like to group things that are interlinked. So you have to drag it around. There is some like automatic layout that you can do here. If you click with the right button on the white background and you click on relayout, it's gonna cluster everything together like in a big rectangle like it is now. But to visualize the individual parts, it doesn't help a lot. For visualizing more specific things, what I recommend in this kind of visualization is filtering your entities before doing the visualization. So we can go back to the queries browser. You see that all the windows are still open down here. So you can click on the queries browser and let's filter the classes again because there's more than 500 classes. Let's filter the classes inside of this selection by name. So you can click here on this arrow, click on add a child query. So it's pretty much like a subquery is a query that's going to run over this already existing query. You can select a string query, select name because we want to deal with the class name, include substring, and so let's take all the classes that have the word entity on them, where the name has the substring entity. And so you see there are 37 classes with entity in the name. So let's propagate that. And you'll see that the architectural map automatically follows my filtering. So you see that now we have a lot less classes, it's filtered. Now we can see more clearly there's a lot of things around entity. If you don't want the behavior that you just saw, so if you don't want the visualizations to automatically update when you are rewriting your query, you can simply come here on the top left side and click freeze. And so now if I change my query, and instead of entity, I want to get any classes with the letter A, and I propagate that, you see that the architectural map is still on the previous state. If I click on follow, then now it's going to start following again, whatever I select here. So let's look for star, or 5 classes. Now if I propagate, the architectural map will follow. Okay, so this is an overview on the architectural map. So after this overview of the architectural map, I would like to show you more visualizations. So let's close our architectural map, and let's go back to the queries browser. And now I'm going to select one specific entity, because for this visualization, it usually works with one central entity. So instead of selecting all classes that contain the word entity, I will change to equals. So there's just one class that is called exactly entity. I'm going to propagate that. And then we go to Moose butterfly map. And it takes a while to open. But then here it is. So you see the entity class in the middle. And on the left, you see all classes that use entity. So here you see test entity, static shadow, a lot of stuff. And you can see that these are classes by right-clicking them, then going to inspect. And you see here it says a Femix Java class. So the names of the entities are always shown here on top of the inspect window when you inspect anything. So you can see these are all classes, Java class. Entity is of course a class as well. And then here on the right side, you see everything that is used by or that is in entity. So for example, you see this add, this is a method, okay? And you see entity action map, this is a class. This tag is an annotation. So the butterfly map can give you this idea of dependency between entities. For a specific entity, who depends on it and who it depends on. You can also move things around. By default, it keeps this butterfly format, like with two wings, and one on the left and another one on the right. So for the butterfly map, that's it. I'm gonna close it. Also, I want to show you the co-usage map. So you go here on Moose, co-usage map. Now it's gonna be empty because we are only propagating entity and it's just one class, and this visualization needs multiple classes. So let's change back to include substring entity. Well, now we have 37 classes. We can propagate them. You see that we see one square for each class, but we're not seeing the methods because they have not been propagated with our data. So let's get the methods for these classes as well by doing a child query. Then you choose scope query, and then we go down. So we want to see everything that is from the classes down. So what is inside of the classes? So the methods. Let's select methods. There are 359 methods we propagate. And now you will see some classes with methods and also some individual methods with their attributes and variables. You see that, for example, collision entity is a class. It's a big rectangle here. If you click twice on the window, it's going to be full screen. So collision entity is here. Then you see the smaller rectangles inside of entity, and when I hover them, you see that they are highlighted, and sometimes they are highlighted in multiple places. I'm going to show you why in a moment. But basically, it's through this highlighting that you can see what is being called or being used in common between these classes and methods. So for example, let's look for collision entity inside of our source code. You can go back to VS Code or whatever code editor you're using. So I just want to remind you that we have here in the same folder Lady Engine and VerveineJ. Let's look inside of Lady Engine for this class, so for collision entity. So I was doing that already. So you can look for collision entity. You're gonna find it here in the list somewhere, collision entity.java. Then you can press Ctrl B to hide the search menu. Then let's focus only in the code. So you can see there are many attributes here like collision, collision box height, collision box width. You can see the same things here. Collision, collision box height, collision box width. But you see that it says when links from this container. So this is only being used in this container and down here in the get collision box width, which is a method. But it's not being used by other classes. These attributes are only being used by this class. But you see that when I hover here, it says links for class. One links from this container, 36 links from 26 local containers. So it's been used by other classes and methods. But then you might ask yourself, how come there's an attribute called class inside of this class? Because class is it's a reserved word, right? So you shouldn't be able to create an attribute. But the thing is that when the code is being parsed, it gets this calls for collision entity.class. So here it's using reflection to get the class object for this class. This is understood by the parser as an attribute, as if I was trying to access the attribute class from collision entity. And so this is why it says here that it's being used and repeated in all these classes. But what it shows really is that all these classes are using reflection to access its own class attribute. So, but if it was really an attribute that is commonly shared between the classes, you should see something like this as well in the visualization. Kind of a long rectangle, a wide rectangle. You see that the width of the rectangles here changes depending on how frequently they are used. And so as class appears a lot of times in a lot of classes and methods, it's pretty wide. And for example, uh, collision box height, it's only used in a couple of places, so it's a kind of a small rectangle. So this visualization is much more powerful, let's say, but the basic idea is this, seeing things that are used in common. So I'm going to close it, and I'm going to open the distribution map. So, but for the distribution map, I'm going to use only the classes. So I'm going to delete this child query. You can click on the arrow and then remove query. Then you click on the line again. You see it says 37 classes selected once again. Then you propagate. Because I think the distribution map is very useful when you want to see many classes and what's inside them. So you can see the differences in size between the classes. So for example, we see entity has a lot of methods and attributes. And then for example, entity comparator, not so many. Or entity emitter, not so many. This is good for comparing the sizes. And then you can always drill down in the visualization. I could click on emitter and then say that it is a method, and then you can see different details inside of each entity. So what are the implicit variables, invoked methods, outgoing invocations, parameters, things like that. This is widely vary on the model that you're using and on the parser that you're using, but the VerveineJ provides us this amount of information for these entities. And so I'm going to close this as well. Moving on to system complexity. So system complexity looks a bit hard to read without a bit more explanation. But basically what you're seeing here, you can understand better by clicking on settings. you see here on the left height metric, width metric, and color metric. So height defines the height of each one of these rectangles. It's going to be defined by the number of methods inside of the class. The width metric is going to be defined by the number of attributes inside of the classes that we propagated. And the color metric is the number of lines of code. So basically, what you can see here is for each class, you can kind of have an idea of its size or its complexity by different metrics. So for example, if I hover over this one, this is the entity class. It's kind of a square, so it has a equal height and width. So the number of methods is kind of proportional to the number of attributes, and you see it's almost completely black or dark gray, so it has a huge number of lines of code. If we take a different class like entity spawned event, so this one is much smaller, but it's still kind of wide. So it means that by being wide, it has a reasonable amount of attributes, but much less than entity. Doesn't have a lot of methods, and it's kind of light gray or white, so it doesn't have many lines of code. And then you see here that there are some arrows. You're also seeing here the inheritance relationship. And so, for example, you see that entity tests is kind of very tall. The height is very large, but width not so much. So this is a sign that it has a lot of methods, but not a lot of attributes. And it's kind of dark gray, so it also has a lot of lines, many lines of code. So this is how you can read this system complexity visualization. And I think very generally that's what you need to start using Moose. It has a lot of other stuff that I barely started covering. And before I finish the video, I want to show you one more thing that you might find useful, which is tags. Moose comes with a tagging system, which you can access here on Moose tag browser. And you can click this plus sign down here to create a new tag. And tags are ways to group your entities by some kind of grouping that you find meaningful. And this might vary completely depending on the system that you're analyzing. So for example, here we are analyzing Lily Engine, which is a game engine. And we know game engines come with different modules that do different stuff. So for example, I know Lily Engine has a physics system. So maybe I want to group all classes that do physics stuff in my system. So I can create a tag, I can choose a color. Let's choose kind of a green. And I'm going to call it physics. Physics. You can input a small description like physics stuff in the game engine. Not very technical description, but don't worry. You can also create categories for grouping your tags, but for now we won't use that. We'll just create a tag, a plain tag. You add your tag, and at first you see here an entities in tag, it's empty, right? So no entities are being tagged with this tag. And here on the left side, you see all the entities queried, so all entities that we queried and propagated. So here I search for all classes that include the name entity. You're seeing lots of things here with the entity name. But now I'm gonna change it for physics. There are three classes with physics in their name. So I'm gonna select the three, propagate. Now you see the three here. And then you can add them one by one to the tag. Or you can click this here and assign all of them, or remove the tag from all of them. You can do it all at once. Here I'm gonna tag these three classes with the physics tag. But then now I'm gonna show you an example on how you can use it. You can use it, for example, in the distribution map. But let's go one level up. Let's say that in the distribution map I want to see all packages. So I will see all Java packages and the classes that they contain. But then I can deselect the classes here. and I can remove this child query as well. I want all the packages that exist in my application. Then I can propagate that, and then I can go to the distribution map. And here we see all the packages, including physics. There's a package with this name, with the physics classes like physics engine, physics test, but here we still don't see the tag highlighted in green. But we can do that by putting it full screen, going to settings. There's a button here called tags. You click on change, you click on plus, and then you'll see all the tags that are available to you. You can click on the ones that you want. Here we have just one. You can select multiple by pressing Ctrl and then clicking the ones that you want. Then you do OK, OK, and OK. And then you can see down here that now inside of the package physics, you see the classes physics tests, physics engine tests, and physics engine highlighted in green. And then as I showed you before, you can inspect and see things specific to these classes like their methods. This is very helpful to help you visualize your information better because there's so many classes and methods and packages, and sometimes you want to highlight something specific, and the tags are very useful for that. You can use the tags as well on the co-usage map, on the architectural map. It's a very powerful concept, this concept of tagging your entities inside of Moose. You just have to make sure that you are first selecting the things that you want to tag, you tag them, and then you might want to select something different to show in the visualization. As long as everything is marked as follow, everything will update accordingly. And always remember to first do the tagging and keep the tag browser open before you open the visualizations, because if you close the tag browser and go do something else and later you open the visualization might not update. So remember to open the tag browser first to go into Moose tag browser. Okay, and there's one more thing that I almost forgot to mention. But if you want to keep the state of your Pharo image, so all the visualizations that you created and the queries that you created, if you don't want to lose your work, don't forget to go here to Pharo and save your image, or save and quit if you want to close the window. If you try to just close the window normally, it's always going to give you the prompt if you want to save the changes before quitting. So always remember to save. And as you start working with more models and with larger models, you might run into some trouble with the loading speed of your image. It might take a long time to load, and it might become a very large image. So what you can also do is come here to system and do image cleanup. It might help if you run into this kind of problem. Even though I think if you are working with small models like this one that I show you today, probably you'll never run into image size issues. So I hope this video was useful for you. This is an overview of Moose. I intend to record other videos in the future explaining other more specific topics that I skipped today. Feel free to leave your comments and suggestions. Thank you very much.